Not a model failure, not a prompt failure, a context failure. Every time an agent loses the thread, repeats itself, contradicts its own instructions, makes the wrong call on step 7, it ran out of the right information at the right time. The model is fine, the context was wrong. Open any tutorial. There is a box. Type your instructions here. Add a system message. Hit send. That is the mental model that ships to production. One box, one input, one chance to get it right. Most developers spend 80% of their time optimizing that box. The other 4 layers do not exist in their mental model. In production, those 4 layers are what fails. A prompt works in a demo. One user, one request, one response. In production, your agent runs 100 turns. It calls 8 tools. It reads 3 documents. It hands off to a sub-agent. By turn 12, the context has drifted. By turn 40, the agent is a different system than the one you tested. Prompt engineering optimizes turn 1. Context engineering architects all 100. Instructions: memory, state, tools, history. 5 distinct inputs into every LLM call. 5 distinct failure modes. Most developers engineer one. Context engineering means you design all 5, not as features, as a system. Each layer has a cost. Each layer has a decay rate. Each layer has a failure signature. You will recognize yours by the end of this video. Your system prompt lives at the top of every context window. It is the only layer that does not change during a session. Most developers treat it as a dumping ground. Long paragraphs, contradictory rules, optional behavior described alongside hard constraints. A well-engineered instruction layer is a specification. Short sentences, 1 rule per line. Priority order explicit. Ambiguity is a bug. Every ambiguity costs tokens to resolve at runtime, and the resolution is probabilistic. Short-term memory lives in the context window. It expires when the session ends. Your agent forgets the user's name, forgets the decision made in step 3, forgets the constraint established in turn. 2. Long-term memory requires external storage. A database, a vector store, a structured file. Without it, every new session starts from 0. The agent is stateless by default. Stateless means no learning, no continuity, no personalization. You have to build memory on purpose. State is not history. State is not memory. State is the current snapshot. What step the agent is on, what decision is pending, what the last tool call returned, what changed since the previous turn. State must be explicit or it will be inferred. An agent inferring its own state from conversation history is an agent that loops. It rereads 40 turns looking for the answer. It should have been told directly. State collapse is the leading cause of agent loops in production. Every tool definition is a JSON schema. That schema consumes tokens before a single call is made. A typical tool schema runs 150 to 250 tokens. An agent with 20 tools burns 4,000 tokens on schema alone. Before context, before history, before the user message. Those are 4,000 tokens not available for memory or state. Tool selection is not a capability decision. It is a context budget decision. Every tool you add is a constraint on everything else. Conversation history is the fastest growing context layer. It grows by 1 turn every turn. At 200 tokens per turn, a 200,000 token window fills in 166 turns. But your system prompt takes 2,000. Tool schemas take 4,000. Memory injection takes 8,000. State takes 3,000. You have 183,000 left for history. That is 152 turns. Most production agents see compaction far earlier. At 50 turns if the documents are long, at 20 turns if tool outputs are verbose. When the window fills, the model summarizes. You do not control the summary. The model decides what is important. Instructions fade into paraphrases. State details blur into approximations. A tool constraint mentioned in turn 3 may not survive to turn 60. The agent that was reliable at turn 50 starts making different decisions at turn 60. Not because the model changed, because its context was rewritten without your input. Compaction is not a failure. Uncontrolled compaction is. 5 rules, 1 for each layer. Instructions. Write them as specifications, not suggestions. Memory. Store externally, retrieve by relevance, not recency. State checkpoint every 10 turns into a structured format. Tools. Cap the schema budget at 3,000 tokens. Choose the 15 tools the agent actually needs. History. Prune before the model prunes for you. Summarize proactively. Keep the last 20 turns verbatim. Archive the rest. These 5 rules are context engineering. Most memory systems inject the last n turns. That is recency-based retrieval. It is cheap to implement and expensive to run. A better system retrieves by relevance. What does this agent need to know right now to do this task correctly? That requires a retrieval step, a semantic search, a lookup, a structured query. It costs an extra call. It saves thousands of tokens per turn. At 1,000 turns per day, that is the difference between a $400 month and a $40 month. Every rule in these 5 layers has to come from somewhere. A spec is that somewhere. A well-written spec becomes the system prompt. It becomes the state contract. It becomes the memory schema. It becomes the tool constraint list, all at once. When you write a spec before you write a prompt, you are doing context engineering at design time. That is the only time it is free. At runtime, every missing spec is a probabilistic guess. Guesses compound, that is part 2. Context engineering is not a new tool. It is a new discipline. The model gives you a window. You decide what goes in it in what order, at what priority, with what structure. Every agent that fails in production failed because someone left those decisions to chance. Write the spec. Define the layers. Budget the tokens. That is the job.